Okay, cool. Well, hey everyone, I'm Haley. I will be the presiding officer for today's presentations. I hope everyone can hear me okay. I'm a little sick, so sorry about that. But Calder Bethke will be presenting first, and a little bit of background information about him. Calder received his BA in anthropology from Willamette University and was a Peace Corps volunteer in Burkina Faso, West Africa for 3 years. He is an Indigi FEWSS trainee and second-year master's student studying controlled environment agriculture with Dr. Kachira. He wants to contribute to climate change adaptation and improving food security in arid communities through controlled environment agriculture and rainwater infiltration in soils. Today, Calder will be presenting about implementing economical and smartphone integrated hoop house growing systems on the Navajo Nation. So yeah, Calder, whenever you're ready. Thank you.
Okay, thank you, Haley. Share screen.
You can take the drug to those side to the screen. Drug to those screen.
Oh, cool. Okay. Neat. Okay, hi everybody. I'm Calder Bethke. I'm a second-year master's student studying controlled environment agriculture. Dr. Kasira is my advisor. Today's presentation is titled Economical Smartphone Integrated and Automated High Tunnel Greenhouse Growing System on the Navajo Nation. We've kind of been going back and forth on the high tunnel versus hoop house terminology. They're both forms of greenhouses. First, I'm going to talk a little bit about the Indigifuse program and some of the stuff we've been working on, and then I'll get to this project. I'm an Indigifuse trainee. That stands for Indigenous Food, Energy, Water, Security, and Sovereignty. I'm not Indigenous, but I care a lot about food security and sovereignty. That comes a lot from my Peace Corps experience. The program is NSF funded. I'm also a part of the Transforming Rural Urban Systems Trajectories for Sustainability in the Intermountain West, which is also part of NSF and looks at fuse issues in the Intermountain West. This is something we did for the Indigifuse program. We went up to Dene College this summer for a few days, helping teach the summer internship program. It was called the Teacup program. Jameis Lee, Dr. Kasira and I worked on setting up some hydroponic systems on one of the off-grid greenhouses we're working on up there. And also, as part of my Indigifuse program, I interned with Six World Solutions this summer. They're an organization on the Navajo Nation that, among other things, work in food security issues. So we worked on farms this summer and also visited some hoop houses. At the end of the summer, we got funding to install some solar power systems. This included the batteries, PV panels, fans, water pump, and a temperature alarm system, which I would build. The project that I'm presenting on is an extension of that temperature alarm system. This summer, I built the temperature alarm system, which notifies you when your hoop house is too hot or too cold. And the next step is to try and connect that to automation systems. Helping us with the solar power installations is the PV Warriors group with Rhiannon and Parvana. They do a lot of cool stuff in the Navajo Nation involving PV power. This is a slide that we used at our Teacup summer training, and it looks at food security issues on the Navajo Nation. There's only 11 grocery stores there, and because people in the Navajo Nation live very spread out or very rural, they're over, on average, 20 miles away from the nearest grocery store. So that means people tend to go to convenience stores are a lot easier to get to, but they also have a lot more processed food, less fresh, nutritious food. This is a similar slide, but it looks at the distances from locations in the Navajo Nation to grocery stores that are outside the Navajo Nation, which are obviously even further, but those grocery stores would have an even more diverse set of food because they're closer to city centers and have better access. So what are some benefits of the high tunnel greenhouse, also sometimes called hoop house? The big one on the Navajo Nation, at least one of them, is protection from the wind. A lot of parts of the nation are very windy, and leafy greens do a lot better with the protection of a high tunnel versus when they're grown outdoors. It's also great for extending the growing season. They can extend it maybe till December and then restart it in January or February, at least with seedlings. This is Jaden's high tunnel system. It's made of polycarbonate. And in the summer, it might be tough to ventilate it. So that's where something like exhaust fans would come in handy because, well, we'll get to it. This is Felix's high tunnel. It's got a polyethylene plastic film with a shade cloth on it because it's the summer, it gets hot. And this is Nate's high tunnel, and he's got a strip system set up, but he had been traveling a lot, so he wasn't able to use it this summer as much. That's something that automation can really help with because you don't necessarily have to be around to still maintain your hoop house crops. So high tunnel challenges, a big one on the Navajo Nation is overheating. The sun is pretty strong up there. So ventilation is really important. Even with the doors open, they still get really hot. And environmental controls. Normally with high tunnels, there's not a lot of environmental controls. But then your watering and stuff is based on a person's availability, not based on what the plant needs. So the general objective is for this project now is to demonstrate an economical, smartphone integrated, automated high tunnel growing system by controlling exhaust fans and drip irrigation through sensors and microcontrollers. The specific objectives are to design a monitoring system for the environmental controls, which has already been done, design electronics and circuitry system for sensors, microcontrollers, and transmitters, develop a code for monitoring communications and control, and implement and evaluate system performance as the final step. So this is the system in a quick nutshell. It's made of 3 modules. One module will be in the high tunnel greenhouse. This will have the sensors attached to it and will also control the exhaust fans and water pump for the drip irrigation system. This middle module, this is going to be in someone's residence. It coincides with this piece right here. So what happens is I have the greenhouse module connected to a radio transmitter that has a high range. It can go up to 1.5 kilometers, I think, as an average. And that's so that there can be flexibility of where the hoop house is in correlation with the house's Wi-Fi, because we need to have the Wi-Fi in order to connect to the smartphone. So it sends the sensor data by radio transmission to the house module, which has a Wi-Fi chip in it. And that displays the greenhouse data on an LCD, and then it sends that data to Wi-Fi to the smartphone using the Blink application, which is a up and coming application for home autonomy projects, but also commercial uses as well. This is a screenshot I did of the smartphone application. You can see it can store up to 3 months of data. This is at the house I live at. You can see the AC is working, and you can see the environment. Right now, it measures air temperature and humidity. And I'll show a quick video. Trying to share the video screen.
Just bring it up here to the screen. Minimize this. And then I'm sharing this. So click on stop share.
There we go.
Okay. Then share the video once you put it.
All right, here's the video. So this is the high tunnel or hoop house module. This is the air and humidity sensor. Goes to the Arduino microcontroller. I'm putting my hand over it to bring it to 78 degrees Fahrenheit, which is my set point for the notification on my smartphone to go off. So the signal goes radio transmit to this radio transmitter, which goes to this Wi-Fi chip connected to this display, and then it sends that sensor data over the Wi-Fi to the smartphone. The smartphone now has a notification that it's 78 degrees. Obviously, in a real hoop house, it'd be more like 110 or something, or 100. And this is the display, 3 months worth of data. This lower gauge, that lower gauge there was the radio signal strength. I hope that wasn't too fast. Okay. This is a quick flow chart of the temperature alarm system as it is right now. It's pretty simple. This is a flow chart of the Arduino microcontroller. And the microcontrollers, those are the pieces that require code. But I have it set up so that whoever owns the hoop house, they shouldn't have to code anything. The only thing they should have to code in is their Wi-Fi network and password, which we can do at installation. So the Arduino, it receives the sensor output and it sends that data to the ESP32 module via radio transmission, which then it goes on to send it to the Wi-Fi, to the smartphone, and then it repeats. For the future automated upgrade, it would start, receive the sensor output. It would check if it has received any set point changes from the Blink application. That's how people are going to control the exhaust fans and the drip irrigation. I'm not sure if they'll actually be able to turn it on and off through the smartphone. I'll have to look into that as I get closer to that step. Right now, it's just they'll be changing the set points of when they turn on and off. After receiving, if there's been any changes, it sends that sensor data to the ESP32 resonance module as it is currently doing. And then it has some decisions. Is the temperature above a certain set point? If it is, turns the exhaust fan on. If it is not, it keeps going and it checks is soil moisture level below the certain set point. And if it is, it turns on the pump or a solenoid valve for a designated time period. And then it goes and loops back to start. Some benefits and advantages of this project. It makes high tunnel management easier. You have to worry less about overheating. Also, with the LCD display, with the residence module, other household members can also help keep track of the greenhouse as well. Less labor because you don't have to worry about ventilation as much. You won't have to worry about watering. You won't have to be on site as much. That's a big issue with hoop houses. A lot of people, so there's been a lot of hoop houses being put up on the Navajo Nation, but then in general, people can underestimate how time consuming they can be. And this makes that easier. You also have more productive plants because the drip irrigation will be coming on more optimal times. It'll be based on when the plants need water, not based on labor availability. Also, it's engaging with smartphone notifications. I think that's pretty cool. You get reminded. You can even set custom notifications. It's low cost. Currently, this the temperature alarm system is about $120 to make. And you could probably half that if you bought your products from Alibaba or AliExpress, although you wouldn't necessarily, those products may not have been verified. With the automation system, if you don't include the fans and water pump, it'd probably be it's going to be maybe about $140. It's replicated easily, and it gives you flexibility of distance in terms of where the high tunnel greenhouse is and compared to the residence. Whereas, Wi-Fi, Bluetooth, they have a shorter range, they may not be as reliable. This radio transmission system is got a lot more range. How is this system different from other automated systems that I've read in research papers so far and online projects? Well, most commercial options still remain expensive and complex. The radio transmitters that I use enable flexibility of location for the high tunnel and the house. And for the situation, it's a unique mix of sensors, microcontrollers, and software. This is a picture of the air and humidity sensor. It has to be aspirated with a computer fan. If we don't aspirate it, it can be up to 10 degrees higher, which will give us off readings. This is a prototype container for the Arduino, and this is the breadboard without any circuitry in it. Obviously, we would also be shading it as well. And these are my acknowledgements, and it's 15 minutes, and I can take questions if there are any.
Awesome. Yeah, thank you so much, Calder. We have about 5 minutes for questions.
Radio transmission, there's a plug into the Arduino and run on 5 volts.
Yeah. Yeah, the question was if the radio transmitter plugged into the Arduino and ran out 5 volts, and that's correct. Right.
General question, you're talking about control, not familiar with the Arduino system as such, but that would probably consist of just like relays and such.
Yeah, I'm still looking into that.
Can you repeat the question? We can't hear them.
Yeah, so Brian asked about the Arduino and future controls and what that would consist of, relays and such. And yeah, I haven't, that's what I'm looking into right now. That's the step that I'm on, and I'm looking at different relays, and I have to look at relays that are powerful enough to handle the load. And also, so the Rhiannon and Pravana from the PV Warriors, I'll be going up in a little bit to help work on some of the solar power systems, and then we'll figure out how much power the relays have to turn on and off. So that's still, yeah, work in progress, but yeah, relays.
I think Dr. Kit has a question in the Zoom.
Yes, thank you. That was a great presentation, and I liked the video to show how it all got put together. My question is, I noticed that you said it needed Wi-Fi to connect from the residence to the phone.
Yeah.
How widespread is the Wi-Fi, and what's the connectivity in the Navajo Nation?
All the hoop houses that we are working at, so we're looking at installing this system on it. So we're working on installing the temperature alarm system and the solar power on at least 4 hoop houses, hopefully a few more. This system, I'm hoping we'll install it on at least 1, maybe all, but I need to talk to people about that as well. But everyone does have Wi-Fi that we're working with.
Okay.
I'm not exactly sure what the Wi-Fi situation is, though, on average on the Navajo Nation.
Just a thought that maybe like you could do the radio transmission, but then you could do the Wi-Fi. Or could you like it? I don't know.
Yeah, yeah,
We didn't have Wi-Fi.
yeah, yeah. I guess so. The idea of Wi-Fi would be like if they were somewhere else, like in town or something, or if they're traveling, But yeah, Bluetooth would be good because it would be at least a good compromise, because then they get that notification whether or not they're looking at the LCD at the house. I did have a buzzer set up too that would make noise when it got to a certain temperature, but that has it keeps beeping when it shouldn't, and it's kind of annoying, so I turned it off.
So the purpose of the notifications, the phone, is that just for information or can they control the?
Currently, they with the current system, with the temperature alarm system, they cannot control. And it's just to let them know, hey, it's too hot, you need to change something, or too cold. And then they can get to see the data over time. So if they've made changes, they'll be able to see how effective their changes were. In the future, I hope that with the smartphone, you'll be able to change the set points of the automation. So you'll kind of control when it turns on and off, but you won't directly say, okay, turn on, okay, turn off. That might be possible, but I'm not for sure about that yet.
Sorry to interrupt, but that's all the time we have for questions, unfortunately. Thank you so much, Calder.
All right, thank you very much.